So for this one, we are looking for the area that is inside the circle, but outside the cardioid. So we are looking for this region right here. Everybody would agree with that? Hopefully so. Okay. So if we're trying to find that specific region, what do you think we need to do first? When we do our area on a rectangular coordinate system and we're looking for the area enclosed by two different curves, what do we have to do? Yeah. What do we normally do if we're looking for the area between two curves? We have to figure out where they intersect, right? To figure out what section that we're looking at. And Nick, yeah, we're going to talk about that in just a second, what you said, because that is what we're going to do. But first, we got to figure out where they intersect. So we just set the functions equal to each other. And that ought to give us what? Cosine theta equals 0. Or theta is equal to pi over 2, 3 pi over 2, etc. Everybody good there? We might also note that negative pi over 2 is one of those values. Everybody good with that so far? Okay. So then we need to decide what our limits of integration are going to be. Now, we should know that the section in the first quadrant is the same as the section in the fourth quadrant. So if we want to, we could just do the first quadrant and then double it. Or if we wanted to, we could do the entire fourth and first quadrants. So when we do the area between curves on polar functions, we got to be extra careful about our limits of integration, because both of these, this one, if I plug in 0 for theta, the cardioid starts right here at the pole, and the circle, if I plug in 0, it's going to start over here, right? At angle of theta equals 0, r is 1. And it's going to go this direction. And same with the cardioid, it's going to start here and go this direction. So they intersect at pi over 2, but then they intersect again at 3 pi over 2. And so if I were to try to do this as an integral from pi over 2 to 3 pi over 2, I'm not going to be getting this section. I'm going to be getting stuff over here, right? The stuff that's going on between pi over 2 and 3 pi over 2. So we couldn't do those limits of integration. We have to do negative pi over 2 to pi over 2. Does everybody get that? Does everybody see that? Hopefully that's okay. Alternatively, we could just do from 0 to pi over 2 and double it. So anybody have a preference on doing it from negative pi over 2 to pi over 2, or from 0 to pi over 2 and doubling it? Either way will work out just fine. Generally, I prefer to just do it the easiest way, which is going to be a 0 to pi over 2 normally, having a 0 in there, and then doubling it. So we're going to do 2 times this integral. And what is our outer r value? Our outer r value is the circle, right? So we should have 1/2 r squared d theta, and then minus, and then what's our inner one? It's 1/2 the integral of the inner one, which is 1 minus cosine theta squared d theta. And remember, we need to square those and put the 1/2 in because that's the formula that we developed for finding the area of the polar curve. So everybody okay with that? So our 2's and our 1/2's can cancel. And I could have written all of this inside of one integral if I wanted to. I don't know why I decided to write it as 2 different ones, but could have all been written as one integral. So let's cancel out the 2's and the 1/2's and simplify what's inside of there. So the 2's and the 1/2's go away. We've just got an integral from 0 to pi over 2 of 1 squared, which is just 1. So we got 1 minus, and then distribute out the 1, what was it, 1 minus cosine theta? So 1 minus 2 cosine theta plus cosine squared theta d theta. And the 1's cancel out. We end up with 2 cosine theta minus cosine squared theta d theta. So far good or no? And that integral becomes an integral from 0 to pi over 2 of 2 cosine theta minus 1/2 of 1 plus cosine 2 theta d theta. And now we should be able to integrate that, yeah? We should end up with integral of 2 cosine theta is 2 sine theta. This is a 1/2, so that's just going to be a minus the theta over 2. And this is minus 1/2 cosine 2 theta, which ought to be minus 1/4 sine 2 theta. And that's got to all be evaluated from 0 to pi over 2. And the sine of pi over 2 is 1, so 2 times 1 is 2, minus pi over 4, and then minus 1/4 of the sine of pi, so that's minus 0, right? And then minus sine of 0 is 0, 0 over 2 is 0, and the sine of 0 is still 0, so that's all 0. And that in part, we end up with 2 minus pi over 4. Everybody good with that? No, if there's no units attached to it, I don't need you to write units squared. Never hurts to. I mean, nobody's going to mark you down for it if it's talking about area. So sure, we'll put it in. Everybody good with that? All right. Now we've got a circle and another cardioid. We want to find the area of the region that is outside the circle, but inside the cardioid. So outside the circle, but inside the cardioid should be right there. Yeah. So what do we first need to do? It's not as obvious probably with this one right away where they intersect. So we're going to have to really set these two things equal to each other and see where they intersect with each other. So we end up with 2 equals 3 plus 2 sine theta. And so if we solve that, we end up with sine theta equals negative 1/2. And what are the theta values there? Theta ought to equal 7 pi over 6 or 11 pi over 6 and so on. One that we might also want to think about is negative pi over 6. All right. So take a second and see if you guys can figure out which limits you think we should put in order to figure this out. So what are our limits going to be? What do you guys think? Which values are we going to choose? Yeah, negative pi over 6 to 7 pi over 6 is correct, Elon, right? Because it's 0. We're at this point at 0, and we're at this point at 0, and we're traveling this direction. So just before that, they should have intersected at negative pi over 6. Here's pi, they should be intersecting at 7 pi over 6. So the integral that we should set up ought to be 1/2 the integral from negative pi over 6 to 7 pi over 6 of the outer r value squared. And what's our outer r value? That's the cardioid, right? Yeah, you could do negative pi over 6 to pi over 2 if you wanted to, and then double it. That'd be fine. But we're going to do it this way since we've already started it. Negative pi over 6 to 7 pi over 6 of our cardioid squared, 3 plus 2 sine theta squared minus the circle, which is 2 squared d theta. Everybody good with that? All right, so sorry about that. We'll distribute out the 3 plus 2 sine theta and combine it with that minus 4. And what do we end up with? We should end up with 1/2 of the integral from negative pi over 6 to 7 pi over 6 of 5 plus 12 sine theta plus 4 sine squared theta d theta. And how are we going to simplify down the 4 sine squared theta? Same way we've been doing, right? 1/2. So we're going to have negative pi over 6 to 7 pi over 6. 5 plus 12 sine theta. And then 4 sine squared theta. Sine squared theta is going to be 1/2 of 1 minus cosine 2 theta. And so that ought to just become a 2 times 1 minus cosine 2 theta, or plus 2 minus 2 cosine 2 theta d theta. And from there, we should be able to integrate pretty easily, yeah? Everybody good or no? So we should end up with 1/2, and then we should have 5 theta, and then minus 12 cosine theta, and then plus 2 theta. And then what was the last one? Minus 2 cosine 2 theta, so that should just become a minus sine 2 theta. Everybody good with that? All right, so we're going to have a 7 theta evaluated at 7 pi over 6. So what's 7 theta evaluated at 7 pi over 6? That ought to be 49 pi over 6 divided by the 2 ought to be 49 pi over 12. And what's the cosine of 7 pi over 6? That ought to be what? Negative root 3 over 2, right? So that's going to be a negative 6 root 3. And then it's going to be a negative 3 root 3. And then it's got a negative in front of it. So that should become a plus 3 root 3. And then we already did the 2 theta with 5 theta. The minus sine of 2 theta, that's minus the sine of 7 pi over 3, which is the same as the sine of pi over 3, which is root 3 over 2. And so half of that is minus root 3 over 4. And then we'll do the same for negative pi over 6. So the 7 theta over 2 ought to become a negative 7 pi over 12. And the cosine of negative pi over 6 ought to be a positive root 3 over 2. And then the negative root 3 over 2 times a 6 ought to make that a negative 3 root 3. And then the last piece should be the sine of negative pi over 3. Sine of negative pi over 3 ought to be negative root 3 over 2 with the negative, and the 1/2 makes it negative root 3 over 4. Everybody good or no? And what does that simplify down to? (49) plus 7 is what? 56 pi over 12. 56 pi over 12 ought to be 14 pi over 3. And then 3 root 3 plus another 3 root 3 is 6 root 3. So we have 6 root 3 minus root 3 over, I don't know, just 6 root 3, right? Oh, that was a plus. Yeah. So, yeah, we got that fixed. Sorry, Nick. Yeah. I just realized that. So 6 root 3, and then it's minus root 3 over 2. So that ought to be plus 11 root 3 over 2. Missed a little sign there. Sorry about that. And just for you, Darius, units squared. Good or no? Any questions or issues with that? I'm not sure why there's just a blank page there. That's because I think I just made a blank page. That's why. All right. Now we want to find same two functions, but the area of the region that lies inside the circle, but outside the cardioid. So that's this little section down here. So this time, our outer function is going to be circle 2, and the inner function is going to be the 3 plus 2 sine theta. And what are the limits going to be this time? We need to go from here to here. So those limits ought to be (7 pi over 6) to 11 pi over 6. Everybody good with that? It'd be a 1/2, and then the outer one is our 2 squared minus our inner one, which is our 3 plus 2 sine theta squared d theta. And we'll try and just kind of fly through this one pretty quick. This is going to be a 4 minus a 9, which is going to give us a negative 5. I'm just going to sort of write all the simplification down here real quick. So it's going to be a negative 5 minus a 12 sine theta plus the 4 sine squared theta. And 4 sine squared theta is 4 times 1/2 of 1 minus cosine 2 theta. And if we simplify all that down, we're going to have a negative 5 plus a 2. Sorry, this is all being distributed with the minus sign. So a negative 5 minus a 2, which is going to give us a negative 7 minus a 12 sine theta. And then that ought to become a plus 2 cosine 2 theta. Everybody good with that? All right, and then if we integrate that, it should become negative 7. I forgot my 1/2. Negative 7 theta, I'll just throw the halves in there. Negative 7 theta over 2 plus 6 cosine theta. And then plus, what does that become? Plus sine 2 theta, or plus 1/2 sine 2 theta. We got the 1/2 out in front. Good or no? And evaluating all that out, we should end up with negative 77 pi over 12 plus 3 root 3, I think. And then minus root 3 over 4 again. And the last one, minus what was the other? I think that's 49 pi over 6, is that right? Or 49 pi over 12 with the 1/2. And then minus a 3 root 3, and should be a plus root 3 over 4. Does that look right to everybody? Just kind of doing that quickly. Hopefully I remembered what we had on the previous page. Good or no? And simplifying that down, let's see, negative 77 minus 49 is, what is that? What does that come out to be? Negative 126 pi over 12. 21 pi over 2. Okay. So that's a negative 21 pi over 2. Plus what? Let's see, that should be another 11 root 3 over 2. I made a mistake, which I just realized. This is a negative right there. So those are getting added together. You guys got to follow along with my arithmetic. Make sure I'm not plugging things in wrong. Right? That's a negative 49 pi over 12 because that was a negative 7 that we had out there. So now what does that become? Now I think that ought to become, let's see. Yeah, negative 7 pi over 3. That's better. All right. Good or no? Getting the idea? Now let's see if we can get through 2 more here in the next 4 minutes. So same 2 problems. Now we want to find the area that's inside the circle and inside the cardioid. So that's going to be this section right here. And we're going to do this one really easily because what section have we already found that could be useful? That little green section. So if we take the full circle minus the section in green, which we already had, right? We just found that in the previous problem. That ought to give us just that one little section. So our full circle ought to be pi times our radius squared. And then we're going to subtract from that our answer from the previous one, which was negative 7 pi over 3. And what was it? Plus 11 root 3 over 2 again. So we got 4 pi plus the 7 pi over 3, which what is that? 19 pi over 3. And then minus the 11 root 3 over 2. So sometimes if you've already done some pieces of one, you don't necessarily need to do all of them. You don't have to actually do an integration setup for this one. And in fact, it's going to be really difficult to find something to set up to integrate this one for. You'd have to find this little bottom section first anyway, and then just do what we did. Everybody good there or no? All right, let's do one more. Let's see if we can find the area enclosed by just one petal of a rose curve. So 4 cosine 2 theta is our curve. So first off, we need to find our limits of integration. And so a petal will start and end at 2 consecutive values when the R value is equal to 0. So 4 cosine 2 theta equals 0 tells us that cosine 2 theta equals 0. And what does that give us? That gives us 2 theta is equal to pi over 2 plus 2 pi n. As well as what else? Also 3 pi over 2 plus 2 pi n, which tells us that theta is pi over 4 plus pi n, and 3 pi over 4 plus pi n. And so what are 2 consecutive values at which theta is equal to 0? Should just be pi over 4 to 3 pi over 4. So we're going to integrate 1/2 of the R value squared d theta, which is going to put, first off, what constant out there? Square the 4, that's 16, times the 1/2 ought to be an 8. 8 times an integral from pi over 4 to 3 pi over 4 of cosine squared 2 theta. And what's cosine squared 2 theta simplify to? Ought to be 1/2 of 1 plus cosine 4 theta, so the 1/2 will get applied to that. And now we should just be able to integrate that, right? That ought to become a 4 times theta plus 1/4 sine 4 theta from pi over 4 to 3 pi over 4. And we'll have 4 times 3 pi over 4 plus the sine of 3 pi. What's the sine of 3 pi? That's just 0, right? Minus pi over 4 plus the sine of pi, which is just 0. So we've got 3 pi over 4 minus our pi over 4, which is 2 pi over 4, or pi over 2, times the 4, which gives us 2 pi units squared. Everybody good with that or no? Make sense? Doesn't make sense?